Today we're going to talk about magnetic fields. Our learning target is, I can explain how magnetic poles interact. Our essential questions are, what is a magnetic field? What is the shape of a magnetic field? Where are magnetic fields strongest and weakest? And why does a compass point north? So first, let's talk about what a magnetic field is. In this diagram here, this shows a magnetic field, and you could actually make this diagram yourself. If you took a bar magnet, which we have illustrated right here, you placed it on a table, and then you took a compass and you placed the compass next to the bar magnet and drew an arrow where the compass is pointing. So for example, you put the compass right here and the compass would point in this direction. So you draw an arrow there. You place a compass here and the arrow would point to the left here. So you draw an arrow there. So on and so forth. Here it would point to the right. So you draw an arrow here. And you would end up with this diagram, which is a magnetic field. So the definition of a magnetic field is the space around a magnet where it applies magnetic force. So we can see where the magnet actually affects things, and you would see that the compass is affected very greatly as it's over here, but as you get farther away, the compass is not as affected. So the magnetic field is where the magnet actually affects other magnetic objects. So when we do this, you can also see where the magnet is strongest. Where the lines are very close together is where the magnetic field is the strongest. Where they are farther apart, the magnetic field is not as strong. Now, if a magnetic object enters this magnetic field, the magnet will either attract or repel another magnet. So let's take a look at what that looks like. So I have a diagram here that shows what we were looking at just before. If you have two unlike poles approach each other, so the north pole of a bar magnet and another bar magnet with the south pole, we know that opposites attract, and therefore there is a strong magnetic field between the two. If you have two magnets come together and you have the north pole of each face each other, you will have them repel and you will have a magnetic field that looks like this, where it's very weak between the two. We know this is true because like repels like. Now, you can actually see the magnetic fields with iron filings. So if you took a bar magnet and you put a bunch of iron filings around it, you would see the magnetic fields that we illustrated over here. And so this is a single bar magnet. You can see that the magnetic fields are strongest at the poles because the most iron filings are there. You have B here, where you have a north and a south pole facing each other. And so the iron filings between those, there's a lot right there. And that is because the magnetic field is very strong between the north and south pole. Opposites attract. You also have this right here where you have the same pole, the north pole facing the north pole. And we can see there's no iron filings between those two. That is because the magnetic field is very weak right there. Now, I want you to pause the video really quickly and make sure that you've drawn a diagram of all three types of magnetic fields we have here. A single magnet, an opposites attract of two magnets, and like repels like of two magnets. So go ahead and pause the video and draw those diagrams. Now, the Earth is actually a giant magnet. This is because we know that the interior of the Earth is a liquid iron core. And so because there's that liquid iron and the Earth is spinning, that actually creates a giant magnet. And so the Earth has a magnetic field. Now, the magnetic field of the Earth is called the magnetosphere, and this is the area surrounding the Earth that is influenced by the magnetic field. We learned about this when we learned about the layers of the atmosphere. Now, the magnetosphere serves a very important purpose. It actually protects us from harmful solar winds and from harmful radiation from the sun. Because it's magnetic, when charged particles from the sun approach it, it is actually able to deflect them. So why does a compass point north? Well, because the Earth is a giant magnet, that means the Earth has two magnetic poles. And so a compass is going to point towards the magnetic North Pole. Now, the geographic North Pole is at the tip top of the world at 90 degrees north. However, the magnetic North Pole is at 81 degrees north. And this is because the liquid inside of the Earth is always moving. And so, actually, the magnetic North Pole is always moving, but it's never perfectly aligned with the geographic North Pole. So, there's a difference between the magnetic North and geographic North Pole. Your compass points towards magnetic North, but that's obviously not the perfect north. So, this is what we call magnetic declination, the variation a compass shows between geographic north and magnetic north.